This is the fifth video on L'Hopital's rule. We're going to do another indeterminate form. This one is 1 to the infinity when we take the limit. So in our example here, we're going to have to do some manipulation. So I'm going to rewrite this. But first of all, to show you that it's 1 to the infinity, cosine of 0 is 1. 1 over x is 1 over 0, which is 1 to the infinity. So we're of that type. This is a typical strategy when you have an exponent that you've got to get out of there. I'm going to rewrite this as y equals the limit of the cosine of 1 over x, and I have to do this because I'm going to take the natural log of each side. How we typically get exponents out is we use the logarithm rules, which allows us to move the exponent in front of the log. So let's do that. So I have to take the natural log of each side. Can't just do it on one side. So the natural log of cosine of x to the 1 over x power. All right, so I am not going to use implicit differentiation here. I'm not going to take the derivative of the left ever. We're going to deal with that at the end. So we're just going to continue to write ln of y on the left until we're ready to mess with it. All right, so again, I mentioned using the logarithm rules. I can move the 1 over x in front of the natural log. It's 1 over x times ln of cosine of x. I don't know that I need the parentheses there, but that's okay. And then, I mean, really, 1 over x times that, we just put the x in the denominator. All right, so now if I evaluate this at 0, I get ln of cosine of 0 over 0, which is ln of 1 over 0, and ln of 1 is 0, so we have 0 over 0. So now it's in a form where we can use L'Hopital's rule. So I'm going to, again, take the derivative of the numerator and the denominator separately. So let's use L'Hopital. Again, I keep ln of y. I'm not messing with that. All right, now the derivative of cosine, of the logarithm ln of cosine is 1 over cosine of x times the derivative of cosine of x, which is negative sine of x. That's my numerator. That's the derivative of ln of cosine. So remember, ln of u is 1 over u du. So 1 over cosine times derivative of cosine is negative sine. And the denominator is elementary. The derivative of x is just 1. So now we have ln of y equals the limit. And please keep writing this. Negative sine over cosine. Okay. So what do we do here? Well, sine over cosine is tangent, right? So ln of y equals natural log of x approaches 0 of the negative tangent of x. Well, if we evaluate tangent at 0, whether it's negative or not, we get 0. So we have ln of y. So this equals 0. So ln of y equals 0. So we're not done because we're solving for y. We're not solving for ln of y. So we essentially do e to both sides. So we have, because the base for ln is e, so y equals e to the 0, which is just 1. So the limit of our starting equation here, our starting cosine of x to the 1 over x, is in fact just 1.